Hello. Okay. So we are live. Waiting for Marcin Ignac. Okay. Refresh. Okay. Hello everybody. Let's see if this is working. Hi. Okay. Hello everybody. Oh, there's 10 people already. Great. Good to know. Yeah, welcome to the first stream. Where I'll be talking about nodes and generative design. And okay, 8 people watching. Great. So maybe quick introduction what it's nodes. And so nodes is a live coding environment developed here at Variable, a studio I'm running together with Damien and Simon. And we think of nodes as a kind of canvas for creative coding and creative thinking. Oh, hello, Alexandra. And you know, nodes is basically a visual code editor, so you're not constrained to any particular form of output or project. And we use nodes for, well, I can stop that. We use nodes for 2D stuff, 3D stuff, and data visualization and generative design and so on. And today I thought, you know, as my first stream ever and not even sure if this thing is working, I thought I might go through, you know, some basics and kind of roughly follow the tutorial we have on our website, but you know, do it live and you can see more or less like what's the thinking process or how would you approach a project. And oh, Damien's there. Okay, cool. So yeah, so let's get started. And I already have nodes open. I mean, you can download nodes on our website, nodes.io, and available for Mac, Windows, and Linux. So hopefully it should work for you. So because nodes, it does come with a bunch of examples that you can use as a starting point for your explorations with code. But today I'm gonna start completely from scratch. And okay, this is awkward. The stream is like 30 seconds behind, which is fine. So I'm gonna start new project. Oh, it's disturbing a bit. I'm gonna start a new project. Click here and give it a name, and let's call it Marcin Nodes or Node Stream 01, because I hope there will be many of those. And give it a name and create a folder. So the first time you open the project, there's a bit of compilation happening and maybe installing a missing module or so, if you have any required. So with that kind of done, let me just close this window, it's a bit disturbing. Okay, yeah, with that done, we kind of welcome by an empty canvas, and there are 3 distinct elements. So on the left we have where our graph and code will live. If I double click, I can create a new node. So let's say I choose custom template, which means it's an empty node. So my node will live here, and here will be our visual, or the kind of visual canvas, the outputs, so to say. And then we have inspector, which shows like the properties of the currently selected node, and we have a helper panel with console logs and whatnot. So a brief maybe mention what we're gonna try to achieve here. So some time ago I tweeted this kind of artwork I published on Hikatnunk NFT website, and it's a mosaic of circles and rectangles that are kind of following roughly this noise pattern, and this kind of noise pattern is called Perlin noise. And if you just do quick Google search, it will become quite obvious what is happening. So this Perlin noise will create this kind of cloud-like darker and brighter areas, and we'll use those to drive different shapes, and depending if you're like above or below 0 level, to switch between different shapes here. There's an excellent website called Scratch Pixel that goes in depth about noise and all that things, and I'll link it in the kind of stream notes on YouTube after we're done. But yeah, it's more or less what is happening here. And if you open nodes, there's at the very bottom, at the top, here, yeah, there's a tutorial that you can open, and I'll give you like also an even overview how to create similar piece from scratch. And I'll create mine in a bit different way, just for the sake of this stream. Okay, so yeah, sweaty hands and trackpad doesn't go well. Yeah, so if I press delete, okay, let's go and delete this now. So to create a new piece of code that we called node, you double click and choose a template, and we don't have any templates right now, there's only one custom one. So that creates an empty block. And now I can double click and get, you know, like a code editor. And that's like a first distinction, because while you can have, you know, like library of nodes or like set of templates of built-in nodes, we don't ship with any by default, and we kind of encourage you to create your own library of blocks that you keep using and building your own art. And or use one of our, you know, provided examples here. So because I'm gonna create art with HTML canvas, like Nodes is based on browser technology, so everything you do can use any of the browser technologies available. So again, link to the Canvas API, where you can read more in detail how to control shapes and color and so on. Yeah, and if anybody has any question, okay, cool, there's some people there. If anybody has any questions or something is not clear, like the stream is a couple of seconds behind, but I'll try to like answer questions that appear on the channel as I notice them, so to say. Cool. So here's our custom node, and we'll call it canvas. Okay. So here's my canvas, and if I double click to enter it, I will start by creating an HTML canvas. So const canvas document create okay, I'm gonna do so many typos. Document create element canvas. Okay, and if I do it, nothing will happen because it's just created memory. We have to add it to this kind of div container or element. So for that we use graph scene container append child and canvas, and still nothing on the screen. And in order to kind of understand what's happening, I can go to show developer tools, because this is Electron, so basically a Chrome browser. And if I click here, I can see that we have this section, which is our scene container, and we have our canvas element. So it did get created, it's just transparent and invisible. So in order to give it a color, we have to draw something. Oh, we can actually do this canvas style or border as 1 px solid black red, and that's a bit of CSS. And now what happens is like we created yet another canvas. Okay, so what I'm doing, sorry, I'm pressing shift enter to recompile. So every time I press shift enter, this whole code is evaluated and executed, and this new canvas is created. So first thing that we should add now is like whenever the node is destroyed, we want to remove the canvas. So now if I recompile it, the previous canvas is destroyed and the new one is created. And of course the previous ones are not deleted because they're already there. So I would, okay, I'll press escape to exit this. I will say graph save, and I'll save that graph as generative 01. And I will reload it with Command R or nodes reload. And then that will reinitiate the whole scene, and now I can see there's only one canvas. So if I go here and I keep like recompiling because I want to add more and more code to this thing, then only one canvas is always alive. Cool. So in order to draw in HTML canvas, we need context. So I'll just do const ctx canvas context, get context. And we have some basic autocomplete here for, especially for built-in nodes and HTML canvas APIs that help you navigate the web APIs. Okay, so I have a context, and now I can do something like ctx fill style, and let's make it white. This is CSS hex color, and ctx fill rect canvas width and canvas height. So now if I recompile it, this 2D drawing context should set the fill color to white and draw a rectangle with the size of the canvas. Oh, it's black. Okay, spelling too much F, one letter too much, so it's white. And let's say I don't like this red color, but I want the canvas to be nice, Instagrammable size, so width will be 512 and canvas height is 512. Okay, and we can close this and we see that it's there. Okay, so that's all great. Here's our canvas, and that's it. So in nodes, we can create connections between pieces of code, and I will create new piece of code, also custom template, and call it clear. So I want to create piece of code that will clean the canvas with color of my choice. So in order to do that, I can open this thing and say const color node in. So node in function creates an input port, and I could color in as a convention. That's like an input parameter. Call it color. And now here's a tricky part where I specify color as an array of 4 numbers, RGBA, and from 0 to 1, not like 0 to 255. That's because how WebGL likes it, and you use nodes for mostly 3D and WebGL, so that was the kind of convention here. And if I recompile this, now whenever I select that node, I see that parameter here. Okay, there's a question: what are effects when you might want to add other elements, say the graph, other than canvas? Yeah, so what I'm gonna show today, I'm gonna create all the UI from scratch, kind of by myself, and we might go through some examples to kind of show how you can use template and create more complex things like database or 3D at the end of the stream. But this is like from 0 to hero kind of introduction. So this is give me like a control for vector of 4 floats. But if I specify option here that it's actually color, not just a vec4, then I'll get a color picker. So now I have a color picker, but these elements are not connected. So how do I connect those elements? In order to connect those two elements, we have something we call triggers. So I can create one, let's say here, and I say const trigger out node out trigger trigger out. Okay, and this will create output port, and I can create similar port here const trigger in node trigger in and recompile. And now this node is grayed out, but okay, we'll get there. It's still grayed out because even though that connection exists, there's no data transferred between those nodes. And in order to do that, we need to trigger the trigger and send it some data. So because we're gonna work with animations, in order to do animations in HTML canvas and in JavaScript and HTML, I use something called request animation frame that will basically call a function that you define that consists of drawing code up to 60 times per second. So I'll create a new function called draw. And I'm sorry, this is like might look a bit complicated and why I have to type so much to get the rectangle on the screen. But hopefully by the end of that stream, you'll kind of see how it all makes together. Because the beauty of this node-based approach is that you have to do it once and then you can use it forever. So I have my drawing function and I'll say request animation frame, which means like please you call that function when you're ready to draw, and then after we do it once we have to keep doing it. And because this will cause infinite loop, whenever we destroyed our canvas, we should say we should keep track if it's still drawing. So I can say let is drawing it's true, like if not drawing, return. So if the canvas has been destroyed and we're no longer drawing, then we should stop calling that function. And in order to check if it's working, I can create something like console log, JavaScript log, say blah. And if I recompile it and see the dev tools, I see the log. It keeps printing 60 frames per second. You can say date now, and it keeps printing the current time in milliseconds. Okay, so this is working. So now there's this connection and we're gonna send some data there. So I'm gonna say trigger out, trigger, and we're gonna pass canvas and context. So this creates an inline JavaScript object and passes this to 2 parameters downstream every frame. So now in my clear function, clear node, I can respond to that. So trigger in on trigger, as a JavaScript shortcut for function definition. You can also say function probes like that, more classic way, or the shorter way. And now if we do console log here, probes, we can see every frame we get the canvas and context. And because we have that context now, I can say const ctx, and then ctx fill style, I don't know, red, and ctx fill rect, and we'll need canvas width and canvas height. Okay, I'm gonna say canvas is props canvas. Okay, so it's red. And if you change here, because the canvas keeps drawing, whenever I recompile code, then this color is changing. Now the question is, how do we use that color? Because it seems like, oh, here's RGBA or HSL or hex code, and while I hit this parameter, if we print this color now, so I can show you, like we can do node log color in value. Does it appear here or not really? Okay, let's do console. Oh yeah, it appears with a delay. So if I choose a red color, it's like 1000, and we can use that because you can say const color is color in value, and then we can do here something called string interpolation in JavaScript, RGBA, and color 0 times 255. We can create like RGBA string. And I'll explain in a second what's happening. So we can take that color and assign it to something like called comment. So node comment. It creates a hex. Okay, so let's copy this text again to see what's happening. Yeah, so now I have a comment here that kind of explains the red, green, and blue parameters that are matching those, and modify the canvas. Does it work? Yeah, canvas color. Okay. I don't like this comment too long. Okay, so now we have a node that clears the canvas 60 frames per second with the same color. So let's add another trigger here, const trigger out, node trigger out, and pass the data further downstream. Trigger props. So now we have input and output port, and what I'm gonna do is I'll copy and paste that node, so I have two clearing nodes, and append it here. So now it's canvas and then cleared again, and if I change this color to something, it should overwrite it. Okay, and I'll rename it to grid. Oh, I can see Simon and Damien are doing tech support on the channel. Cool, thanks. Grid. And if you go back for a second to this thing, this is basically a grid of elements that's on X and Y axis, and that's what I'm trying to do here. So because I have context and canvas and I have a color, now if only I can create two for loops. So I'll say I have a constant here with number of elements like 32, and I'll create two nested loops. Okay, X and or I and J. So now I have two nested loops, and I will use variable n here and here. And so this gives me number from 0 to 32, and if I say ctx fill rect, I don't know, I times 5 and j times 5 and 4, does it work? Okay, because I clear the canvas. If I don't clear the canvas, yeah, I'll get 32 by 32 squares of this color. So if I make it red, it's gonna be red. Now, a couple of things. First, we want to cover the whole area of the canvas. So in order to do that, let's do what can we do? Okay, let's say I know there's a magic library called PEXMath, and that has some function that I really need. So I can go to packages and search for it, PEXMath. Okay, and add it, like find it on the list from npm and add it. So npm is like a repository of JavaScript libraries that are yeah, mostly open source, but not always. So now if we do install a dependency or third-party library, fortunately we do have to reload the project, and that's the current limitation. So if I reload the project, I can now go here and require that library. So okay, yeah, let's do this and I'll explain what's happening. Require pexmath. So pexmath is the library, and that pexmath library has a utils object. Let's do it, maybe let's do it like this to make it simpler. And that utils object has a map function, and utils map, if you go to pexmath documentation and find utils, okay, utils map. So it can take a number and then a range and then remap to a new range. So if, let's say, if I go from 0 to 32, I can remap it from 0 to the width of the canvas. And that's what we're gonna do. So I'll create new variable called x and say utils map from 0 to n. And now this will go from 0 to a canvas width. And I will create a new variable called y that will remap j from 0 to n to canvas height. Okay, so if now I draw the rectangle on x and y, it will cover the whole canvas. And now I don't really like that those guys are touching the edge and these guys are not touching the edge. So if I add 0.5 here and 0.5 here, it's nice and even. Well, almost, because if those squares are bigger, then they're not centered again. So in theory, I should like subtract half of them, their size, and now everything is nice and centered. Cool. So we have this grid component, and like this code really bothers me, so let's install another library, and there's another library made by us called pexcolor. You don't have to use it, and just something I'm most familiar with, and it has like utilities for color conversion. So instead of writing this ugly code, I can just require const get hex require pex color, and I can comment this out and say ctx fill style get hex from this RGB color. And if I change the color here, it's much simpler and cleaner than this kind of multiplication and string interpolation and so on. But that's the thing, like I use pex color, but you can use T3 scale or HSLUV or our various color palette libraries and so on. So we have the grid and we know how to use colors. So let's add one more parameter that will replace that n number here. So I'll say const count node in count, and I'll say 32, and that could be it. We could just like use that value here. So now if I resize it, it changes the number of rectangles, but I don't like how this is not a integer number, so we can fix that by saying precision 0, which means like 0 floating points of like comma or dot, and now we work on the integer numbers. So if I do like 16 or 32, whoa, that's a bit too much. 32. Yeah, 32 is a nice number, so let's stick with that. And what's happening here now is that I'm drawing those rectangles here, and I would like this shape to be customizable. And because I have trigger in and out, I can just continue doing what I was doing and just create a new node, or I can even copy paste that. And I'll call this throw rectangle. Throw rectangle. Whoa. Throw rectangle. Connect it here and delete all that code. And just, yeah, delete all that code. And now if I go here, I can take that trigger out, and instead of drawing rectangles here, yeah, okay, I need to recompile that. Okay, so this is drawing rectangles, and I commented out. There's a shortcut command / on Mac that comments out the line, and if I recompile, the rectangles are gone, and instead I will trigger the trigger out with the same props. So now for each cell in the grid, I will draw whatever the next node in the order is drawing. Now if I say ctx fill rect, and let's draw a rectangle that's like 0, 0, 10 by 10, this will just draw rectangle in the one corner because we're not utilizing this x and y position. So we can pass this data in the props. We could do something like this in modern JavaScript, where you copy all the properties from this props object and add x and y properties to it. So now here we receive canvas ctx x and y, and we can prove that by saying node comment. This will give us object no, JSON stringify. Will that work? We get x canvas and context, and if I recompile it, oh, do I get trigger props x and y? Ah, sorry, I need to remove that. Now we're getting canvas context x and y. So I could in theory use that, what is it, props x and props y, and now cover that grid. Again, taking my radius into consideration. Yeah, so half the width. So that's cool. And if you go back here, you can see that, you know, I have both rectangles and circles. Rectangles and circles. So I can just create another node and basically copy paste, rename it to draw circles, maybe change the color to be more obvious. And drawing circles in HTML canvas, you use arc function for that. So it says ctx arc, and there's, I think, radius. Well, let's check the docs because I'm never sure. Throw rectangle, paths, arc. Yeah, where is it? Line 2, or loops, arc. XY, start, radius. Okay. So we have today ctx, begin path, props x, props y, radius 5 from 0 to math by full circle, and then it says ctx fill path. Does it work? Okay. ctx fill, and that draws circles. Now what I did here is like if I have something connected and press shift and drag it, I can disconnect it. So now I have circles, and again shift and drag, I can like reconnect it. So now I have one algorithm drawing rectangles and another one drawing circles, and you can switch. I can have like, you know, small circles and big circles, and I can like switch between them. But I can also try to use the Perlin noise we mentioned at the beginning, Perlin noise, and basically let it decide which of the shapes I should be drawing. So I'll create another trigger. So I have 2 ports, and connect circles to this one and rectangles to this one. And now in my grid, I'll save it and import new module, pex random, because it contains function to create the Perlin noise. And now here in the grid, I'll import the module const random require pex random, and now I have this object I want to pass down the stream. So I'll say new props, and I can do something like random noise 3. It's 3 because it takes x, y, and z. And say x, y, 0 const f, okay, or t f, okay. So that's my random value, or random value. And now I can say that should go from -1 to 1. And now if my random value is above 0, I'll trigger the first trigger, and if my random value is below 0, then I'll use the second trigger to out, and I'll pass the new props. Okay, and this crashed, was 0. So if something crashes, we try do the best and catch the error. So this node caused the error, so if I click on it, it will display what happened inside the node that caused the problem. Okay, so the problem is that we call it, there's no new prop variable, and that's because it's called new props, and I said new prop. So if I fixed it and recompile, now sometimes we have squares and sometimes we have circles, so it's working. And as you can see here, depending on the frequency of the noise, we can get more or less detailed patterns. So let's add a frequency to our grid. And we have color count and const frequency in node in frequency, and we make it a float number. And we use that frequency here, where we call the noise function. Okay, let's read the value, freq value, and we use that frequency to multiply our x and y. Okay, so if I decrease the frequency, oh, you can't wait. Let's do like this, 0.2. Does it work or not? Can I do like 64? Oh yeah, okay. So if I do that, it's a bit slow. I go back to 32. Yeah, okay, maybe 50. Yeah, okay. So now, as I modify my, okay, it's moving too fast. So maybe what I'm gonna do is divide it by 100. Okay, so that's like allows us to kind of observe the scale. And yeah, so this whole thing is now moving. And what's different from this, this state of the artwork where we are compared to that, is that this artwork, the noise field itself is moving. So in most of our projects that involve any form of animation, we like to create a timer. So let's create a timer node, and I'll just copy paste the clear node. And because I want the triggers and I don't need color, and the time node will keep track of time. And in JavaScript, you can always get the current time using date.now, and it's in milliseconds. If I divide it by 1000, I get seconds, and you can keep track how much time pref time is. Date now divided by 1000. So you can keep track of how much time passed since we drew last frame. So const delta time is now minus pref time. So that should give us time in milliseconds, in seconds, and we can keep track of our total time and editor time, and we can display it here. Node command is time. So now if I let's call it time as well. Time. So if I connect this node here, I'll stop drawing. But you can see that's running too fast. 1000. Okay, it's running too fast. It's exponentially growing because I forgot to set pref time is now. Okay, and now it grows a bit slower. So if we put that total time and delta time into our props, well, you can use the destructuring again, and we say time and delta time. And the nice trick with modern JavaScript is that if the property and the value of the object have the same name, you can skip it. So you can just do like this. And now in our grid, in the noise function, we can just add it here, props time to our z-axis, and this whole thing starts moving because this Perly noise function I have, it operates in 3D domain, so to say. Yeah, let's find noise 3D. Yeah, so it's like a cube where there's X, Y, and Z, and as we modify, as the time is increasing, we move on the x-axis, and you kind of traverse that 3D volume of noise, which if you remove the black parts and leave the white parts, it looks more or less like this. So if from the 2D point of view, it's animating, but because the volume is continuous, so it animates smoothly. And that's why it looks like those kind of like a droplets of water kind of joining and disconnecting and joining and disconnecting. Okay, so maybe to make it more interesting, we can do something like count here, let index 0, and add a new property index, so we'll number the squares and circles 1 2 3 like 0 1 2 3 4 5 6 7, and pass that data to the drawing function, so we can do something interesting with it. And we can say index plus plus. So now if I go to rectangle, and instead of using that green color, I will create a new, I will copy paste this as a new node and disconnect this and call it draw colorful rectangles. Yeah, British spelling. I mean, it wishes for. So now I can create an array of colors here. So I'll say const colors, and I'll create let's say red and green and blue color. And because we know const color index props index, instead of getting color from that color picker, I'll remove that color picker, we don't need it. I can just assign a random color, or maybe not random color, but like index modulo colors length. So like the first rectangle will be red, and second blue and green, and red, green, blue, and red, green, blue. If you recompile it, you get this this craziness. And the funny thing is that instead of okay, so we can add this index color, or we can pass maybe the noise value as well. So we have this random value, then we can pass it as well. So maybe I can use that to get the color index. So I say const color index, it's gonna be random value, const random value, props random value, and I know that random value is from -1 to 1. So maybe we remap it here. Okay, I have utils, so I could say utils map random value from -1 to 1, and from 0 to number of colors. But that's not gonna work great. Okay, I'm getting lost here, diverging from the idea. It's not gonna work because color index yeah, it's not working. Well, okay, there's a couple of reasons why it's not working. I like to put things in comments because I can see them real time. So first of all, this is a floating point number, not an integer, and to address an array we need an integer. So to fix that, I can do math floor of color index. Okay, now it's working. But because I'm in the first part of the grid, or like of the first branch, where numbers are only positive, I should be remapping from 0 to 1, not from -1 to 1. Okay, and now I can see all three colors. Okay, so create a plasma. Draw plasma rectangles. But the great part is that, like, if I'm bored with that, I can always roll back to this version and keep this part of the grid, or even do something like, okay, let's say I overwrite it here, and I can do a check that if props x is more than 10, only then draw. Oh, maybe not x, what, 100? Okay, yeah, why props x? Interesting. Because it's in pixels. Okay, so if canvas width divided by 2. Okay, so I can do like split screen rendering, but I don't need that. Okay, now what else we can do? So the same way we animate properties inside the like parameters of a function, like here doing the props time, we can also animate those parameters quite easily, either manually, or we can just create another just go crazy here. Create new nodes. Okay, we copy paste this and copy paste this and remove everything here, and this node will be called, yeah, just probes. Oh, this node doesn't even need a trigger out. Yeah, just this. We call this node LFO, which is like low frequency oscillator, LFO. And whenever it triggers, oh, okay, Marcus is there, Andy. Okay, plasma stream. Okay, trigger on trigger, probes. We can set the value here, create new param, const value out, node out value. Which will create output port, and if I assign values 0 there for now, and because we have time, we can, I don't know, we can take like const value is math sin of time, and again that's from -1 to 1, so you can do time 0.5 plus 0.5. So now we have number from 0 to 1, and if I multiply it by, let's say, 64, this will now oscillate. Node comment. If I plug it in, it will oscillate between 0 and 64 and go back like a sine wave. So now if I do the same thing where I do math floor, so I get integer, now I can plug it into to count. Whoa, is it working or not working? What did I do? Value. Okay, I'm not setting the value because the values are always 0. So I say value out, set value. Okay, and now the grid is also animating, so like everything is animating. And now, okay, great. You create a piece of art, and yeah, let's say, okay, let's create another very useful node I use all the time, and let's copy paste this one again. Okay, so this is boring, right? This copy paste. So because I have to keep like deleting code, and it's very time consuming. So what I can do is I can take this node, call it custom with triggers, and click this magic button called save node as template, which changes color to white. And now whenever I double click it, I can just create new node with templates, with triggers, so that saves me time. And now if I recompile it, it will kind of detach from this trigger template instance, and now it becomes custom node. Toggle. Then I will call toggle, but this template is mine forever, so I can keep creating more custom nodes with triggers now. Easier way. Toggle. So I'll add a button here, const enabled in, node in enabled, and I'll say true, so I get a checkbox. And now whenever this, if enabled is, if that value is true, I trigger, and if it's not, I don't trigger. So I can plug in my LFO to toggle, and why LFO stopped working. What happened? LFO is not working, and what is happening here? Ah, okay, I connected to the wrong port. Yeah. Okay, so this is working, and if I pass it to toggle, And if there's like a visual I like, I can just turn it off, and and it stays at this scale. And then I click it back and it keeps animating. Okay, so that's great. And now, probably like the coolest thing of Nodes is that, can I create template? No, we don't have. Okay, so Andy has a question. Can you create a template from collection of nodes? So that will be called like a patch or subgraph, and we don't have that yet. It's desired, obviously, because you can have snippets of reusable code, but at the same time, what I'm gonna present now is that the thing is that this is JSON if you copy it. So I can just copy it and I can paste the whole project here. Boom. Will it work? Clear. Why it's not working? What did I do? Okay, so this is working and this is not working. And why this is not working? Time. Clear. Grid. Because the count is 0. Yeah, the LFO never triggered, so the count was 0. Okay, so if I disconnect that graph and I have this grid at 40, no, maybe 50. Okay, now I have the same graph that they can, let's say this is the version 1 of the project, and I can just continue and do version 2 of the project. Now you can also clone graph, and I save it as a completely new project. So I have like Generative 01 that can create a new project called Generative 02 and keep iterating on it. But what often happens is that if I go back to nodes and create new empty project called blank 2, we don't have the templates, but so we copy paste a lot. So basically, when you have a new project like this one that has nothing inside, in theory you can just like take this whole thing, copy paste it here, and it'll ask you, oh, there's stuff missing, and install everything for me. And I'll say U01 reload, connect, and yeah, okay, those templates are missing. Why? I know PEX color is missing, so I didn't pick it up. Okay, PEX color, save. Let's see if I can recover from this live stream. Yeah, and the same issue, the trigger was enabled, so the grid size was 0, and it's running. So what often happens if I come up with a pattern, and the thing is that if I happen to copy template and move template to this project, now this project has this template in the library. So what often happen, we would develop those mini graphs that are kind of doing this one thing that we like, and just keep reusing them. Yeah, so too many things. Let's close this one so not to get confused. Yes, close it. Bye bye. And now we created the artwork of our dreams. So we can say this is a good thing to start. We have a canvas, and we have a clear node, and we have a time node, and we have some form of grid, and we have a draw rectangle node here, and draw circles. Yeah, these are my templates. So now if I create new graph called Generative 02, don't close it, save, graph, clone graph, Generative 02, and I cloned it. Okay, I cloned it. Okay, let's delete everything. New client comes or whatever, I need quickly a new project in 5 seconds. I create canvas, I create clear, I create time, I connect this to that and this to that, and change the color, and the boss said it has to be pink, and I go here and quickly drop a grid because that's my favorite layout, and draw a rectangle here, and we like up and running in 5 seconds, right? Just because we created this vocabulary. So like, you know, you can say, oh, but this doesn't do 3D, or doesn't do meshes, or doesn't do HSLUV colors or something. Like it doesn't until it does. It's extremely, I mean, of course it requires programming knowledge and everything, but like you can stay at the 2D level and get very far with it. So now we have this rectangle guy here, and I'll copy paste it and put it here. So now it's, and I can change color. And let's say I'm a bit bored by this rectangle of here as it is now, so I'll upgrade it a bit and I'll make it rotate. So to rotate things, we say ctx save. So okay, so if I do rotate by like props time degrees, it will go crazy because the origin of the rotation is on the top left corner. So in order to do, for this to do what we expect it to do, we have to save our canvas state, translate to the position we want to be at, then rotate, then draw our rectangle, and restore our state. And the canvas is already broken. I mean, it persists the state, so I need to reload the project. Okay. And if I do those rectangles a bit longer, so you can kind of see what's happening. They're rotating there. They're rotating there. So now I have rotating rectangle, and I create new template. Rotating rectangle, and save it, and delete the boring ones, and create a new rotating triangle. Change the color, and now now the template magic part 2 is coming into play. So add width and height parameters. Const width in is node in width. It's gonna be 0 and no 10, and height. And I'll use those for drawing, right? So I'll say here const width is this thing and height is this thing. And I'll move by half the width and half the height, and width and height. Okay, so now I can, in theory, control the size of those rectangles. Yeah, not only color, but also like how thick and thin they are. And maybe let's change them to integers because they should be integers. So we do the same, precision 0 and precision 0. Okay, so I'll do height 20. And the cool thing is that because I kept the same name, draw rotating rectangle, if I save it as a template, it will ask me, do you want to overwrite it? Yes, please. And now the other template got updated. So it, without reloading the project, I changed the code of this node, and this code node, because it uses the same template, got updated immediately. So now this node can also be controlled with width and height. Okay, I think this is NFT ready. So let's try to export that. And in order to, so there's two options. Like one thing is just save screenshot from the canvas, and that's more advanced thing is we would like to have an animation. So let's try to save a canvas first. So there's this awesome module by Damien, canvas screenshot, and let's save it, and let's see if it's still running my project. Okay, still running. Okay, so I'll create custom node with triggers because we have a template for that, and I'm gonna add a button here. And to add a button, say screenshot in node in screenshot. Okay. Yeah, okay. Fine. We figured it out. Screenshot in. Okay, and if that the parameter of that port is a function, this will create a button that calls that function. So you can say alert NFT right now. Yeah, okay, creates an alert. Should say mint it or something. Yeah, so let's require that canvas screenshot. So say take screenshot is require canvas screenshot, and well, let's console log it because I'm not sure what's the syntax here. Console log ESM module, so default. Okay. So that maybe quick explanation. Canvas screenshot is a kind of modern type of module called ESM module or ECMAScript modules, and the syntax we require here is from Node.js. It's like a common JS modules. So if you encounter modules within this newer syntax, sometimes you have to do like .default to get to the actual function that this module is providing. So now we have a screenshot, and if you go again, that almost screams from my built-in docs help npm. If you go to npm, find out about this module. Okay, how does it work? Okay, you just call screenshot on canvas, that's it. So what's gonna happen, we're gonna create a flag. It takes screenshot false, and when I click the button, okay, let's go different needs screenshot. Create a, whoa, what's this problem? Okay, needs screenshot. So I click the button, I'll set it to true, and then the next frame I'll trigger it. So because I'm here, I will trigger it, so I will let all this code execute, and then check if the screenshot is needed, set the flag to false, and then call it this text screenshot, and we provide props canvas and save. We call it text screenshot. Okay, so now in theory, if I click this button, if I click this button, it will create a screenshot and go to my downloads folder. Boom. Now I need to find my downloads folder. Downloads. Oh, it's here. Okay. Okay, let's find it. Downloads. Screenshot. screenshot. Should have cleaned out that folder before. Screenshot. Jesus Christ, 5 years of screenshots. Okay, there you go. Yeah, there it is. So we have the screenshot, and now that's just one frame, and that's boring. And what you actually want is a sequence of images. So I will just go to another project and copy a node I have called frame recorder. That does take screenshot, but in a sequence, and it's quite long because it names the screenshots nicely, and it counts frames and count times, and has different take care of different resolutions and so on. And now I'm thinking, yeah, let's see if it works. Just copy paste it like that. So I'll disconnect this take screenshot guy, plug in my frame recorder, and just so if you wonder, like, all of that code would be on GitHub. So yeah, no need to kind of try to recreate it by following stream or something. So now I can say resolution. So how will that work or not? Well, let's see what's gonna happen. So I say I wanna record at 30 FPS, 10 frames per second, and if I press start, it's recording something. Wow, that's super fast. So now if I go to my folder, oh yeah, I can see everything. So it's actually recording. Now if you go to like After Effects or Photoshop, you can actually take that together and put it in a video. Ah, okay, I see what's happening. Look, if you see these frames, they're actually moving too fast. It's not a proper sequence. That's because my time is below the recording. And if you want constant frame rate, that the time should be below recording. And now the frame recorder is smart enough to override the delta time and total time. So if I do start stop recording, let me go here, then all the images are almost looking the same because they're moving slowly. Yeah, and if you put it in the sequence, it should work. Okay. What's the time? It's 1 hour. Maybe we go quickly as we are here. It's the project folder. Another couple of cool things. So like all the graphs are JSON, so you can put them in the Git and version control. Now this is just Node.js project with all the dependencies right in front of you. And also what's cool is all the nodes are plain JavaScript, which means they also can be in Git or can be shared, backed up, and not hidden in some cloud service. It's all yours. And all the templates are here. So because they are here, that means they can be shared between different graphs. So all the graphs, the whole project can use those nodes. So if I save this, take screenshot node and frame recorder, and I go to my first sketch, save. If I go to first sketch, double click here, they are available to me, like frame recorder and take screenshot. And yeah, same issue here. My plasma, save a screenshot of my plasma or frame record of my plasma. That's all waiting to be used. Yeah, I think that's it for now. Didn't plan much more. And if anybody is still there and has any questions or wishes for part 2 and 3, and happy to answer and hang out a bit on the chat. Any questions? Yeah, otherwise I might just play it a bit and maybe add mouse interactivity, but yeah, so let's say we clone graph generative 03. Delete this whole thing. Delete this whole thing. Don't bother with LFO. Set the count to 50. Frequency to 0.2. And slow it down a bit. Slow it down 5. Slow it down, and oh, I know what I wanted to do. Oh, where's my mouse? Oh, that's interesting. My trackpad turned off. Okay, my trackpad died. Oh, if I'm gonna show some more complex graphs. Yeah, I think I probably could, if I can guarantee they will open. Maybe next time actually, because I'll need to make sure it's like, the thing is, like, you know, there are some quite more complex graph with much more code, and they are small, relatively small. So like, is anybody still there, or am I by myself? Because I'm happy to answer any questions or try to find something that's kind of makes sense to show here, but let's see. Workspace X, light mapping, surface color, BST. So oh yeah, I can actually show this one. So that's something I was tweeting about the other day, and if I go file, open project, if I open this guy, let's see if this opens. It's the kind of clone of Blender geometry nodes, or I basically follow a tutorial of how to make a procedural building, something that traditionally you would use Houdini for, and now with Blender people are able to achieve the same thing. So I kind of like borrowed the assets that are free, downloaded the video, and made this like building generator that takes a number of inputs like width and height, and duplicates a couple of assets that are provided, and like window and door and this kind of shop, and yeah, the column and the roof, and clones it in WebGL. So yeah, kind of can explain how it works briefly, but just to show you, like, this graph looks big, and you know, lots of cables there, and so we have a couple of things that are like working on that are not, you know, part of any of the examples so far. But for example, we have this thing where instead of drawing cable from the one part of the screen, we can assign a name to a variable, and then use it across the project to where is it? Oh, it took a while. Yeah, okay, I think it's this one. Yeah, so you can set width, height, and depth, and then use it in different parts of the graph to kind of not avoid the number, like reduce number of cables that are already here, because it's already messy. And this whole thing is actually, I follow the simple kind of method that the guy in the tutorial is doing, and this whole thing is basically duplicated, where yeah, it's 4 times the same graph for each of the walls, and kind of lazy way. While you could create one wall and then like mirror and scale the output to achieve the same thing, but that was like the simplest way to get it done. And yeah, and okay, so well, the cool thing here is that, and that graph is maybe like 1/3 of real world production graph use, but like what I can try to do here, I can create new graph, 3D demo, and see how far I can recreate custom context, how much I can recreate from scratch here. So if I have GL context and then ECS system, which stands for Entity Component Systems. That's how we organize thing in a 3D scene. And I have ECS, and then I have ECS mesh and geom cube. So create geometry and add it here, and then I'll have a geometry system that can create vertex buffers for me, and I can have transform system that takes care of node hierarchy, and I can add a camera to the scene, and then add a camera system and a way to draw GL grid. Did we get something on the screen? Yeah, okay. Camera always. So now I have a grid, and in order to draw that cube, I have ECS draw base color. So this will draw all the meshes with base color. Okay. So great, and let's add sequence here to organize it a bit. So plug in the geometry here and camera here. Okay, so camera a bit higher. So I have a cube, and then because it's a clone of geometry nodes, there is a node that exists in Blender called point instance. That takes an object and a source geometry and places one on another. So if I say geom icosphere, I can create icosphere and then place cubes on the vertices of that icosphere and put it in my geom. Will it work or will it not work? Geom icosphere, geom cube. Oh. Okay, this cannot deal with this, so I need a better renderer that supports instancing. Throw PBR mesh system and PBR program. And this is all black because there's no light. So if I add the directional light to the scene, I get the light, and I can add light probe Point light, okay. Yeah, and I need some transform to move that light around. Is it there somewhere or not? Oh, it's there, but very weak. It's here. Okay, whatever, don't bother with this one. But it's an icosphere, and how do we know it's icosphere? Because if I make it bigger, it gets bigger, right? It gets bigger. And if I modify my cubes, then I have those cubes. And yeah, okay, this is too dark, so I'm gonna add the light probe here. Oh, do I have light probe? Reflection, ECS reflection probe, skybox reflection probe, okay. And HDR texture, and I have one HDR texture here. Can plug in it to reflection probe, add it to my graph, and I need two more systems, which is skybox system and reflection probe system. This all sounds very messy and complicated, but again, you set up it once, and I have meeting nodes here, and you would need to click a checkbox or something, so it's not like it's that much more work. And I need to change rendering to gamma instead of linear to kind of enable better color correction. So now I have those cubes, and because this point instance takes attribute from this icosphere, I can also add random attribute to that geometry that will impact how the cubes are placed. And if I go here and I say vec3 and call it scales, does it work or not? Random float quad, so random attribute scales. Does it work? Offset instances. Okay, it doesn't take offset rotations into consideration. But if I clone this, I copy, say rotations, no, scales, yeah, now this has random scales here. So as I increase, let's see what you have here. Okay, I have color correction. So as I increase the density, okay, so maybe because I moved ahead too much, if I create ECS mesh and plug in that geometry to the mesh and add it to the graph, then we can see the sphere. So that's my sphere, that's like the base of it. So that's why the cubes are where they are. And if I increase the radius, I get more cubes. And if I change that cube to be uniform, or unit cube 1, 1, 1, we have those cubes here. Those, yeah, those still random positions. And now this looks again boring because of lack of shadows. So you can try to add post-processing to this scene. And in order to add post-processing, I need to render my scene to a texture. So I have my render graph, render to texture node. Goes here. Oh, and this needs a resource allocator of some kind. GL resource cache, which allows me to reuse textures from the previous frames for post-processing. And now I go here, render the texture and color, and I need color correction. plug this guy here, and that lookup texture is missing. Texture. Oh, where is my texture? I don't have a texture here. Interesting. I don't have my texture template. That's fine. I don't need this, so I can just comment it out. Quickly recover from the breakup. Okay. Lookup texture. Lookup texture. And we don't need this. And we don't need this. And what's missing? Lookup size. We don't need this. Okay. So now we're drawing, and I need to change gamma correction to this thing. Okay, so this thing is like super bright because my sunshine is bright and my cube map is bright, so I can change exposure here. Okay, and I should have screen space ambient occlusion effect, so I can just plug it into a graph. Okay, it's missing camera. Okay. Yeah, that's why this code is not shipped, because it works until it doesn't. Okay, so now I have ambient occlusion. So if I increase radius of this thing, like that much, we get our shading, and I can say render graph, multiply, and take this color and multiply it by SSAO. So now I have my scene where I can adjust how much shading I want. And yeah, and here is my noisy sphere. And if I have geom, I don't have a torus, but I can just copy paste this thing, recompile it, say to geom torus, and instead of icosphere say torus here, and say create torus, and we have a radius, small radius and big radius. There's big R and small r, and I create torus, and I believe it was major radius and minor radius. Major radius are in value and minor radius are in value, and this goes bye bye. Subdivisions. Okay, R on change and letter R on change. Okay, and now we have a torus where if I increase the big radius and increase the small radius, I have a torus of cubes. Okay, we have shadow mapping system. So if I create one more mesh and add a cube there, so I'm gonna create a floor, and I'll say geom notice transform, and here let's make it big, mesh, geom cube 20, 0.1, 20, okay, 50, 50, and move it down. And if I add this shadow mapping system, that should in theory render scene from a camera point of view. I'm not sure if that's gonna work. Because cube bounds, yeah, I don't think it's gonna work, but work in progress. Yeah, okay, it's hard coded. minus 50, minus 40, minus 40, and then I'm just hacking now. No, it's not working. Okay, no shadows. No shadows in this demo. Paid feature. Yeah, it's all, yeah, Florian said it's all magic once you have the right template nodes. Yeah. So that's the thing, like, I think, yeah, first of all, like, we'll stop here, because that, I think, shows enough what you can do with it. And then, like, there's lots of nodes that are reusable, like context for GL context, and I don't know, this resource cache, or even like this ECS and mesh and PBR shaders and whatnot, because this thing, it's all PBR renderer, right? So I can make it like metallic and make it reflective, and then replace it with spheres or icospheres. Boom, and it's gonna be nice and shiny. So that's all, like, you know, what you can expect from a modern WebGL renderer powered by PEX library or 3JS if you're into it. We have examples with 3JS. So we have those nodes that kind of match our style of working and how we use them in the projects. And like, you had a good example with this shadows that I'm updating them recently, and it doesn't work. And if we distribute them in some form of examples, like those examples, then, you know, ideally those nodes would have to be like npm modules that you can update and upgrade your project and fix the bugs if there are changes in the API and keep moving. But we're still figuring out what's the best way to share that code with people. And for now, that means examples and copy pasting, because things move too fast to have a stable release of a, I don't know, WebGL library. Now, if you do want something stable and don't want to bother, you can just use 3JS, right? And then the kind of 3D aspect is provided, and you use nodes as more like a glue code or scene manager or just interface. But of course there are like quirks, because, for example, in nodes I can just like disconnect this thing and it should be like removed from the scene, and the thing that's being removed from the scene can be a couple of levels down, and your renderer has to keep track of everything and scene graph, but now it also has this nodes graph to maintain. And yeah, so that's why we keep using PEX, because it's more functional, as in like functional programming based, and not that much object oriented, or there's not that much state. So it kind of makes some of those things easier. But yeah, random attribute, let's add another one. Colors, it's typo there again, should say vec quad or vec 4, and we plug this here, and we go here and add colors. Yeah. Oh, doesn't work. scales, colors, back 4. Yeah, okay, it worked now. Yeah, and that's the thing, like you modified it and now this is a new thing, and maybe I should actually save it and upgrade references. And then how do we push that change back to all the people that installed the library or use the library? It's because we also don't want your projects to break, and it's one thing fix code, another thing is fix a graph, and yeah, how things are connected and what to do if a port doesn't exist anymore or there's new ports, and open-ended questions. Yeah. Okay, 2 hours. Think if there's any more questions, how do they say, please leave a comment and subscribe. There might be more. Yeah, otherwise you know where to find me on Twitter, and happy to answer any questions there. And I guess that's gonna be it for today or tonight. Let's see. Twitter, no. Oh yeah. Twitter. Wrong tweet. Where is the stream? Hard to find it. I can stream myself streaming now. Okay. Cool. Yeah, so I think we'll finish here and take it from there. Thank you for coming, and yeah, thanks again to all the 14 to 20 people that joined us today. Bye.